we checked function f at one of two variables x and y. It's equals to f disjunction y with integration. And I hope that you remember about definition of the completeness of the function. So function is functionally complete if it is possible to get disjunction, conjunction, and negation just with this function. And it means that any Boolean function can be constructed from this particular function. Then this function is functionally complete. And we can check if function is complete or not with using 5 classes. It is class T0, T1, self-dual class, monotonic class, and linear class. And for example, let's check this function. If it's a functionally complete function or not. So if this function didn't belong to T0, so it doesn't belong to T0, doesn't belong to T1, doesn't belong to self-dual class, doesn't belong to monotonic class, and doesn't belong to linear class, then this function is functionally complete. And it means that any Boolean function can be constructed from this function. Previously, we did a scheme instead of blocks. Instead of blocks, disjunction, conjunction, and negation. We use just block which realize this particular function. So it is x, y, and this function f1. Inputs, output, it is x disjunction, y or negation, result of working this block. Okay, so we checked T0. So you remember that our function f1 of 0, 0, to 1. So rule doesn't work here because here must be 0. That is why f1 doesn't belong to T0. f1 of 1, 1 equals to 0 also doesn't work here because here must be 1 according to, so it is wrong. That is why f1 doesn't belong to T1. So we checked self-dual class also. Self-dual class opposite pairs must have opposite results. X, Y, F1. x and y. So it is 0, 0, 0 conjunction, 0, all negation is 1. Here, this is 0, 0, 1, and 1, 1, 1, 0. So it is 0 and it is 0. So opposite pairs must have opposite results. It is correct, and this is problem the same, not opposite. That is why function f1 doesn't belong to self-dual class. Monotonic. So finished just monotonic. Okay. So monotonic class. So this is self-dual, and this is monotonic. So monotonic class, you can see the rule on the slide number 4. 6 class, presentation 6 class, functional completeness. And let's draw hypercube for points, for vertices. And we can connect just vertices which have only one difference. So this pair, this pair, this pair, and this pair. And we need to check also points which have one difference. So the rule for bigger point, function must be bigger or the same. So for bigger, so these 2 points, this is less, this is bigger. So for bigger point, function must be bigger or the same. At point 0, function 1. At point 1, function 0, 0, and 0. So let's check. For bigger point, function must be bigger or the same. So it is not correct, because function for bigger point less than here. Function equals to 1, here function equals to 0. Is it clear? Okay. So this is not correct, and it is enough. We can write F1 doesn't belong to monotonic graph. So F1 isn't monotonic. Also, this problem. If, for example, here, okay, we need to check other pairs. If for all pairs, okay, then function F1 is monotonic, belongs to monotonic class. So here is also problem, here is okay, here is okay. If just one problem, it means that function doesn't belong to this particular class. And linear class. Function belongs to linear class if it can be presented as a linear combination. So we have two variables. So linear combination for two variables. It is f1 of x, y equals to c0 plus modulo 2 c1 conjunction x plus modulo 2 c2 conjunction y. So this linear combination for two variables. If in our function three variables, we need to add plus modulo 2 c3 z, for example, and so on, plus modulo 2 and so on. So this is linear combination. Here C0, C1 and C2, it can be 0 or 1. So if it's possible to find C0, C1 and C2 so that the result in each point, like here. So it's possible. It means that it's possible to construct this function as a linear combination. Okay, so how we can find C0, C1 and C2. You have ideas? Like two tables, we truth table and what? Like here is truth table x1, x2, and you are adding two variables.
C1, C2.
C1, C2.
Can we use that?
Table.
In the variables of the report.
So C0, C1, and C2 can be 0 or 1. We need to find here 0 or 1, here 0 or 1, and here 0 or 1. So that this function works like this one, absolutely the same. So how we can have ideas?
Like from infinite from x0, y0, f of f1. So we will get combination of equations, and in solving those equations, we can find the value of C1 and C2. Similarly,
C1 and C2.
So equations.
You mean
yeah, we can find it for three values, and then we will get three equations, and then following those equations simultaneously. I think we can find answers.
okay? So we first of all we can find C0. Yeah. Instead of x and y, we can put 0. Then 0 conjunction C1 will be 0. 0 conjunction C2 also 0. And here will be just C0. And here will be the result of our function. Absolutely right. Great. Okay. So let's use point 0, 0. Our function f1 at point 0, 0 equals to 1. It is left side and right side. C0 plus modulo 2 C1 conjunction 0 plus modulo 2 P2 conjunction 0. Yeah? So, this. Yes. It is C 0 plus modulo 2 0 conjunction C1 0 plus modulo 2 0. And do you remember plus modulo 2? Could you help me with truth table A plus modulo 2B? A plus modulo 2B. 0, 0, it is 0, then
1,
1,
1,
1,
plus
0, plus modulo 2. So 1 plus 1 divided by 2 and rest. Yeah?
Thank you.
0 plus 0 divided by 2 rest. Stop. So 0 plus 0 is 0 divided by 0, rest will be 0. 0 plus 1 divided by 2, rest will be 1. Rest will be 1 and rest will be 0. Another variant to remember if similar than 0, if different than 1, but it is just for memory. It's not rule. It's just logic. Okay, so this expression plus modulo 2, 0 equals to what?
Let's do that expressions. 1.
I hope you remember previous topic, minimization, and you remember how we can get f of a b from truth table with disjunction, conjunction, and negation equals to which expression?
It can be a disjunction B negation.
Disjunction of two points where function equals to 1. Yeah, this one and this one. It is conjunction of what? I think you said the same thing, but from truth table. Previous topic, minimization of total Boolean function. I hope that everyone started to do coursework.
A disjunction, not A.
Not
Disjunction.
Conjunction.
Conjunction B.
B. This one
A conjunction not B.
not B, and between them disjunction. Yeah?
Yes.
So we have not A, B, disjunction A, not B. This is formula of plus modulo 2. So it is A plus modulo 2B. It is very easy for everyone, I hope.
Yes.
Okay, so you can find a C plus modulo 2 0. Yeah, not C, C0, not C0, conjunction 0, disjunction C, conjunction not 0.
Yes.
It is what?
It is C0.
It is C0 plus modulo 2 0 equals to expression. So 0 conjunction something
Think it's 0.
0. This is
C1.
C
C0.
0. Conjunction 1 it is C0. And disjunction C0 and 0 it is C0. So this is C0. Obviously, this is C0 also, it is C0. It means that on the right side, C0, on the left side, it is 1, and it is
Equal to C.
equals C0 equals to 1. So C0 equals to 1. So we found the first so the first C for this expression through the point 0, 0. Okay, let's find C alpha plus modulo 2, 1 equals to what? Plus alpha plus modulo 2, 1 will be what? Sorry?
Alpha 9
Yeah.
and 1
Alpha
Disjunction.
conjunction 1 is junction,
disjunction alpha but not 1.
not 1. Alpha conjunction not 1, and it is what?
It's alpha.
Not 1.
Not alpha.
0. The second part will be 0.
Not alpha. Not alpha.
Alpha the result. Yeah. So not alpha conjunction 1, it is junction alpha conjunction not 1. It is not alpha disjunction 0, it is not alpha. So very easy to remember. Plus modulo 2 0, something plus modulo 2 0, it is something. So 0 just disappeared. And alpha plus modulo 1 means not alpha. Opposite alpha. Okay, Mavis, do you have questions? Okay. Please. Mhm. Okay, so the next, we found C0, and then we need to find C1 and C2 also. It's not possible to find two C for one step, but it's possible to find C1 or C2 first and then the C.
We can find C2 from the next point.
C2
From the next point to 0, 1.
0, 1. Yeah, okay. Let's find C1.
Then we can use the next point, the third point, 1,
C1, which point?
1, 0.
1, 0. So we use 1, 0 point for finding C1. So F1 of 1, 0, it is 0. It is 0. It is left side. And the right side, we know already C0, it is 1. Plus modulo 2, C1 conjunction 1, plus modulo 2, C2 conjunction 0. Okay. What will be here? 0 C2, it is 0. 0 plus modulo 2 something will be something, so it is this part disappeared. Yeah. So it is 0, and this is plus modulo 2 0 disappeared. So this is the result. 1 plus modulo 2 C1. C1. And you remember that it is what?
It is actual, not C1.
Not C1. Not C1. And here 0. So 0, it is not C1. Then
C1 is 1.
C1, it is 9. You can use this expression. So
Yes.
for getting 0, you need 1 plus modulo 2, 1. Yeah, so it's also just both there. Then C2, for C2, which point we can use?
0, 1.
The second point. 0.
This one.
Yes.
Is it possible to use this one?
Yes.
Also, because we know all C, but not C2. So this point or this point is possible. Okay, let's use 1, 0. 1, 0. F1 of 1, 0, it is 0. And the right side, 1 plus modulo 2, 1, conjunction 1. Yes.
0.
Something wrong. 0, 1. 0.
We can also use this one.
Sorry?
We can also find it from 1, 0. It doesn't matter. You can use any font.
Why can't you use 0?
1, 0, it's not possible. Yeah.
It will be obviously.
Use 1, 0, it will be 1 plus modulo 2, 1, 1 plus modulo 2, 3, 2,
Yes.
0. So it is just equation without without derivatives. Okay, so C1 0 plus modulo 2 C2 conjunction 1. C2 conjunction 1 equals to 1 plus modulo 2. This is 0, disappeared, C2. If you have questions, please ask me, okay?
It's
Because it is important for coursework and exam. Sorry?
it's not C2.
It's not C2, absolutely right, or 2. And it is 0. Then C2 equals to 1. Okay. And now we have expression expression 1 plus modulo 2
X.
C1 okay x1 plus modulo 2 y conjunction 1, and it is 1 plus modulo 2x plus modulo 2y. But we know that this expression works for these 3 points. So we need to check others. We need to check others. If you have more variables, for example, 3. So for getting expression, we need how many points? Let's imagine that we have 3 variables, x, y, z. A little bit longer expression, plus modulo 2c3 z. And we need to, and for finding all C, C0, C1, C2, and C3, we need 4 points. 4 points. 0, 0, 4,
Yeah.
0, 1,
Zero.
1, 0, 0, 1, 0, 0, 4,
0, 1.
0, 1,
0, 1, 0.
0, 2,
0,
And?
0, 1.
1, 0, 0, 1. Yes. And with these 4 points, we will get all C0, C1, C2, and C3.
3.
And then we need to check other points. How many other points? For 3 variables.
For 3 variables, 8 points.
Sorry,
8.
8, all points 8.
Yes.
4 we checked, and we need to check 4 more. 4 more. But in our case, just 1. It's very easy because just 1. So let's do it. So point 1, 1. So we know that function f1 of 1, 1 equals to 0. 1 disjunction, 1 all negation, it is 0. It is left side. And right side, our new expression 1 plus modulo 2 x1 plus modulo 2 y1. It is equal to what? It is
It is 0,
0, and this is
1.
so 0 equals to 1.
So it is
It is wrong.
strong.
So it's not possible to present our function in this particular linear combination. It's not possible. It means that function f1 doesn't belong to linear class. And you can see that our function f1 doesn't belong to each of 5 classes. Each of 5 classes. It means that it is functionally complete. It is functionally complete. And previous class, we constructed Boolean function, another Boolean function, just with this function, without disjunction block, conjunction block, and negation block. If you don't remember, please watch the video. Do you have questions? Okay, then I release. Okay, let's check another function. Let's check another function.
So regarding the last question, is it functionally complete or not? So we, I think there is a one that shows that the function which doesn't satisfy all these rules, these clauses, it will be functionally complete.
So the definition of functionally complete function or functionally complete system. If function or system can construct, so if from, so we have system, for example, system, it can consist of just one function, for example, f1 of xy, x disjunction y or negation. So is it system functionally complete? This system is functionally complete if any Boolean function can be constructed with the elements of this system. This is definition. And theorem of Post-Yablonsky theorem. We can check with this theorem, is it functionally complete system or not? If function. If this function doesn't belong to T0, doesn't belong to T1, and doesn't belong to other 5 classes, S,
M,
M, and
N.
So if this function doesn't belong to each of 5 classes, it means that it's functionally complete.
So the last question solve this experiment.
So this function functionally complete. And previous time we constructed another Boolean function, big, complicated Boolean function, just with this one function. And did you watch video previous class? No?
I don't think class.
Oh, okay, so it is important to watch. And about system. Here may be several functions. Several functions. F1, F2, and for example, F3. And so on. If we can find in this system function which doesn't belong to T0, and we can find here function which doesn't belong to T1, and we can find here function which doesn't belong to self-dual class, and also function doesn't belong to monotonic function, monotonic class, and we can also find here function which doesn't belong to linear class. It means that this system is functionally complete. So for each class, we need to find here function which doesn't belong to this particular class. So for example, F1 doesn't belong to T0 and doesn't belong to self-dual and doesn't belong to monotonic. For example, F2 doesn't belong to T0 and doesn't belong to F2. T1 and F3, for example, doesn't belong to doesn't belong to T0 and doesn't belong to linear class. Then these 3 functions together doesn't belong to each of 5 classes. Okay, clear?
Yes.
And basic, it is basic. It is functionally complete system consists of functions, one or several. It is a functionally complete system which is without redundancy. Without redundancy. It means that I don't know, F1, F2, F3. It means that each function important. Each function important. For example, function F2 important for this class, so it is not important. Function F1 important for this class and or for this, and function F3 important for linear class. So this is basic according to this example. But for example, another variant, F1 also doesn't belong to T1. Another variant, another example. This is not important already. So this is important and this is important. So this is not basic, but it is functionally complete system. I can remove F2 And anyway, it will be functionally complete system. Yeah.
Means if F1 doesn't belong to D0, and F2 or F3 does not belong to S, can we say F1, F2 are functionally complete or whole class is like is functionally complete?
For the first example or for the second. So it is just abstract example, abstract. So
He is saying that the S whole class is functionally complete. Are these F1, F2, and F3 separately complete regarding this below chart?
separate,
These
separate,
F1, F2,
they are not functionally complete.
this whole class is complete.
Separate not, because F1 belongs to linear class. So it belongs to linear class, it's not complete,
But can we say
separate.
whole is
But together,
it is
it is functionally complete system. Together, yeah, thank you. Yeah, F2 also belong, so it's not functionally complete, and 3 also. So I put here function. For example, if this function not belong to this class. So separate the okay. So let's check another function and construct basis. And to construct basis. Conjunction. You can presentation by yourself. Here is little bit more examples for you. And look. Yeah, so. And done. Let's check another function. For example, f of f of. Would you like easier or? Okay, easier. F of x, y equals to x disjunction not y. Basic function. So let's function f1, function f1, and function f2 of ABC equals to not a disjunction BC. So the task is to check this function for completeness. If the first, the next, to build basis with this function basis.
Yes.
Basis, it is functionally complete system without redundancy. And the last step, to construct this function with this basis. we need to remove from here disjunction, conjunction, and negation. And we need to use just blocks
Block.
of this function x, y, x disjunction not y at 1. And maybe something else, because we don't know is it functionally complete or not. Something else which we maybe add to our basis to make functionally complete system. Okay, let's check. Very easy, very fast. So P0, F1 of 0, 0 must be 0. Is it true? 0, disjunction, not 0. It is 1. Oh, not correct. Does it belong to T0, F1? T1, F1 of 1, 1, 1, 1, all variables equals to 1 must be 1. Is it true?
Yeah, it's true.
Yeah, it is 1, really. F1 belongs to 1. So it is already not functionally complete, but we need to check other classes for building bases. So 0, 0, 0, 1, 0, 1, 1. Result
0 is 1.
1.
It's 0, 1, and 1.
Okay. Opposite pairs must give us opposite results. Not correct. Here correct, but it doesn't matter because one mistake already means F1 doesn't belong to self-dual class, and it is good for us.
And the next N, monotone.
Monotone. Monotonic. Let's check pairs according to slide. Another way. Another way. Let's check pairs.
0, 0.
Monotonic. F of 0, 0 must be
Less than or
less or the same.
F0, 1.
0, 1. F of
0, 0.
0, 0 must be less or the same of
F1, 0.
1, 0. F of
0, 1.
0, 1 must be less than the same.
F1, 1.
F 1, 1. F of
1, 0.
1, 0 must be less
Less
than
than
the same.
F1.
1, 1. That's all.
That's all.
That's all. Very little because of just two variables. Okay, let's check. 0 less or the same.
Then 0, it is not.
Not correct. So I don't need to check others because I found. But in possible, let's check.
Yes.
Let's check others.
Checking.
Everything, because very just two variables. So let's check. Okay, so 0
It's less than 1, 0.
the
Correct.
same, correct. Okay, correct. So this is true, this is correct. Then
0, 1.
0, 1.
Yes, correct.
Correct. Monotonic.
Yes,
And this one.
it's correct.
Correct. So everything correct, but not the first one.
That's one.
So this is not correct. This is problem. This is the problem. So F1 doesn't belong to F1. And linear class F1 or X or Y equals to C0 plus modulo 2 C1X plus modulo 2 C2Y. Let's find C0. So our function equals to
C0.
C0 plus 0 plus 0. So this is the result.
Yes.
But in your coursework, please do like our previous, very
Check one by one. Like all the step by step.
Yes, step by step, a lot of explanations. Not like this one, please. It is just for you because you already know all steps. Okay. Then we need to find, for example, C1. So it is point 0, 1.
Yes.
Function is 1
One.
here. And here will be instead of C01 plus modulo 2. C1 conjunction 1, it was C1, plus modulo 2, C2 conjunction 0 disappeared.
And C1 become 1.
It means that
C1 is 0.
C1 is
0.
0. C1 is 0. This is here. Okay, let's use another point, another variant, another point 1.
1, 1.
So find C2. Find C2. So function
Is 1.
equals to 1. And the
1.
right side 1 plus modulo 2.
C1 is 1. No, C1 is 0.
Yeah. 0 conjunction 1 plus modulo 2.
C2 conjunction 1.
Conjunction 1. So 1 equals to
1.
Here 1 plus modulo 2 C2. It means that
C2 is 0.
is 0, right? And the last point, it is 0, 1, last point. So function here
Is 0.
0 equals to right side 1
1.
plus modulo 2
No.
plus
Wait.
modulo 2.
C1 is 0.
0 conjunction 0, 0 plus modulo 2 0 conjunction 1.
1.
So disappeared, 0 equals 2.
Equal to not equal to.
Not correct. Not possible to represent this function
Linear.
as linear combination. Not possible, and it is good for us because F1 doesn't belong to linear class. Doesn't belong. So this is one problem. So for getting basis, we need to do what? Forgetting basis.
Forgetting
to do
basis.
what? Basis. Basis.
It's not functionally complete, so it cannot be a base.
This is not complete.
So it cannot be a base.
So for getting basis, we need to add here something else. Something else. X disjunction of y plus something else, which something easier function. Which one?
It's junction 1.
It must be function which is, sorry? So we need to add here, in this future basis something else which is what?
Which one is equal to?
Sorry?
For which one is equal to 1, and there is one more condition where our function was failing, so it has to satisfy those two conditions to make it functionally complete spectrum.
Yeah, so we need to add which function?
Say the
I
function.
didn't hear.
Say the function.
I don't know the function for which we need to have value 1 for the 1 for
We need to add function which doesn't belong to this problem class. Absolutely right. Yeah. We need to find function and add it to this system for getting basis. So this function must not belong to T1. Not belong to T1. Okay. In your coursework, it can be a constant 0, constant 1. Please don't use disjunction, conjunction, or negation because it is operations from full algebra. They are already here. Please use another simple functions like constant 0, constant 1, aggregation, plus modulo 2. Is another presentation. 7th class, construction of function. Okay, 0. Use these operations or these functions. On slide presentation number 7, 7th class, construction of F2 from functions of complete system. So from functions from the basis. It is second step. So we need to get basis. We checked our function for 5 classes and we found that this function doesn't belong to each of 4 classes, but belong to T1. So we need to find here a function or function which doesn't belong to T1. Let's check. Is it belong to T1?
Zero?
Yeah.
What does it mean by zero here?
Constant 0.
Constant
So
zero.
it is function truth table, several, maybe several x1, x2, x3, and so on variables, a lot points,
For all of them.
but everywhere 0. It is constant 0.
Yeah.
F constant 0.
It does not belong to T1.
It does not belong to T1. Not belong to T1. So this is not belong to T1. It is, but if it is functionally complete already, it won't be basis because here will be redundancy. So I can remove this function, and this function will be already functionally complete. So we need to check maybe this function belongs to some else class or classes.
Or no. That's right.
Yeah. For example, it just belong to T.
Yes, T0.
For example, so it is suitable for our example. It is suitable. Okay, comma 0. This is basis. Is it clear why it is basis?
Yes.
Yes.
Is it clear why it is basis?
Because the first one was not complete.
So this is not complete. This is also not complete. But together, they didn't belong to each of 5 classes. So it is functionally complete system and it is basis because without redundancy. Okay. Implication. It is, I hope you remember implication. It will be home task to find implication, truth table, and the formula, not X disjunction Y. And to get this formula from truth table. Okay, home task. Plus modular 2 you already know. Is it plus modular 2, is it belong to T1 or not?
That's not enough.
Yeah. Is it belong to T1 or not? Plus modular 2.
It's not belong to T1. Yes.
1 plus 1 will be
0.
0, so not belong. Not, so it's also possible, yeah, basis number 2, another variant F1 plus modular 2, another variant. Okay, let's use those. So the last step, we need to construct scheme or expression and then scheme of function f2, of given function f2 with the elements of basis 1. Basis 1. So first of all, let's get negation disjunction and conjunction. Not alpha. Or I can get not alpha.
Not alpha
Mhm.
from both of these two.
I have this function and this function. Not alpha. Alpha, it is something abstract. I need to get negation. So I can use something. It can be expression, it can be variables, or something abstract. I need to get negation. I don't have negation law. I don't have negation law. I don't have, but I have block of F1. The result, it is X disjunction Y with negation. And I have constant zero. It can be also something log. Doesn't matter what is the input, but output every time zero.
Can we do like this? Zero disjunction, not alpha, but
Zero disjunction, not alpha. Absolutely right.
and it's equal to
And it is what?
it is f of zero alpha.
Zero alpha. This is the rule, the formula for negation. Is it clear? Disjunction.
Disjunction. We can take not B, not
Double negation law.
yeah.
Double negation law. Okay. Then
So it will be
very similar formula. Instead of y, we'll give
not beta.
not beta.
F of alpha, not beta.
Not beta. And it is
Not beta is f of alpha, f of zero beta.
zero beta. Very important position. Very important position. So this is input first for X. This is input second
Why?
for Y. Conjunction.
Conjunction. Not alpha, not beta, negation. Double negation.
Let's. No,
I mean, no.
De Morgan law.
De Morgan law. De Morgan law.
De Morgan law. Not disjunction.
Not beta. Yes,
Like this.
like this. So
Yeah.
it is f of not alpha, beta.
Yeah. Oh.
But first we have negation. Should we remove the big negation first of all, or we can start from down?
Remove big negation.
Yes.
What? We add big negation with the Morgan law.
Yeah, with the Morgan law.
Yeah.
Yeah, let's go.
One more the Morgan law. Okay. Okay.
F of not alpha.
Not alpha.
And
So disjunction.
beta.
And this one, it is our formula.
Yes.
And this is not alpha, it is X. This is function and negation will be here.
Yes, negation will be there.
Okay, so not alpha,
Beta.
comma,
Is equal to f of two times f of zero alpha.
You would like to get the final.
No, just I will remove the alpha negation.
This.
No, alpha negation.
Okay.
Then to alpha
Then-
negation.
Just
F of 0 alpha,
alpha.
not beta. No, beta. No negation, over the negation.
Yeah, negation big.
Yes.
And F
Of
of
0, this. Yes.
Okay. This is, and it is, I think the same if we use De Morgan law here. So it is not X conjunction Y or negation. Yeah, and it is the same. Double negation here, double negation here, the same. Yeah, you can use the Morgan
Yes.
law here or here, doesn't matter where. Okay. And the time.
Time is finished. About to finish, just 7 minutes.
Yes, let's stop here and next class we will finish this task. So the last step we need to get, instead of this expression just with function f1 just with function f1. Do you have questions?